All right, so let's go ahead and try that again. We're asked to find the r, solve for r. So let's take the equation v equals 1/3 pi r squared h. Again, what we're trying to do is we're trying to solve for r. We're trying to get the r by itself. So the first thing I'm going to take care of is this 1/3. And the way I'm going to take care of that 1/3 is by multiplying both sides by a 3. 1/3, if I flip that 1/3 upside down, that's called reciprocal, I get a 3. That's what I'm multiplying by, the reciprocal. Which means now I have 3v is equal to pi r squared h. So the first step, multiply both sides by 3. I'm trying to get r by itself, and right now what they're doing to that r is multiplying it by a pi and by an h. So I'm going to do the opposite. The opposite of multiplying is divide. So I'm going to divide both sides by a pi and an h. Which means now I have 3v divided by pi h equals r squared. I'm very close here. Very, very close. Since I'm wanting r by itself, what's the opposite of squaring something? Square root. So we're going to square root both sides. This way I can have the r all by itself, which means I've got square root 3v all over pi h. So that was the first part of the question. Solve the equation for r. I just completed that part right there. Now what they want me to do is use that equation in order to find the radius, because that's what r stands for, find the radius, if we have a height of 20 inches and a volume of 1,005 cubic inches. So all we're going to do is replace the v, which stood for volume, with 1,005. We're going to replace the h, which stands for height, with a 20. So this is what I'm working with here. All I got to do is throw that into my calculator and see what number I get. So let me go ahead and give you a chance to put that in your calculator, see what you get. Make sure all of that is underneath your square root. It is going to turn out to be a decimal, guys. What's that? Nope, that's not what I'm getting. Yeah, make sure you use the 5. It's right above the division sign. 138? No.
19.5.
5 is right above the division sign.
I did that. 19 point.
19? Oh, let me see here. What you type in? Oh, okay, I see. Here's what you might want to do, guys. I see what the problem is. This is a fraction. And we need to make sure the calculator understands that this 3 times 1,005 is the numerator, so you might want to throw in some extra parentheses around that. And we also need to make sure that the calculator understands that this part down here is the denominator. So you might want to throw some extra parentheses around that as well. So try it again with those extra parentheses, see if you get a different answer. Do you get something over 6? 138? 138? There you go. Now we're getting the answer I'm looking for is 6.9. Okay, got to use those parentheses so that the calculator does not mess it up. All right, so there it is. That's number 8. Number 9, you're asked to describe the change on the graph. Oh, I just noticed that. Describe the change on the graph when the equation is changed from y equals to the square root of x to y is equal to the square root of x minus 5 minus 2. So they're asking what kind of transformations occur here. Let's start with the minus 5. What is the minus 5 doing to our parent function? Moves it to the right. Now be more specific. Move it to the right how many times? 5. We're going to move it to the right 5 times. What about this minus 2 right here? What does that do to the graph? Brings it down 2 units. Now, in this particular case, there's only 2 transformations, and there they are. Move to the right 5, down 2. On the test tomorrow, I may decide to add an extra one, like maybe throw a 2 in front of the square root. You know what the 2 might do to the graph? Vertical stretch. Vertical stretch. So make sure you include that if I put that on the test. What if I also put a negative sign in front of that? Reflects over the x-axis. Matter of fact, all that stuff, guys, is still over here on the board. Now, I'm going to leave this on for the test tomorrow, If you need a peek over here, go ahead and do it. Let's go to number 10. Number 10, it says that the equation t equals the square root of d divided by 14 gives us the time. That's what the t stands for, time in seconds. For an object dropped from a height of d feet to reach the ground. Determine a reasonable domain and range for this problem. All right, so let's see here. There's a couple of different ways that we can find the domain and range. I think the easiest way to do this is to go ahead and look at its graph. So everybody, let's graph that. Let's go to our calculators. Let's go to y equals. And let's type in the square root of x divided by 14. Oh. Remember, we can't use d. We got to use x. X divided by 14. And you're barely going to be able to see it. It's a very little graph. It looks something like that right there. Is that right? Is that what you're saying? Okay, so that's the graph we're looking at. So what we want to know is what's the domain and what's the range? Well, first of all, I know domain is x. That's what domain is. It's the x values. So if you look at this graph, you'll notice that the x values on this graph start at 0. Starts right here at the origin. Notice that graph goes to the right. And if I'm starting here at 0 and I'm going to the right, are those x values getting bigger or smaller? Bigger. So we want to say that the x values are greater than or equal to a 0. That's what that's saying. We're going to do the same thing with the range here. Range is the y values. Notice again, we're starting here at the origin, so the y values start at 0. Now this graph, it goes up. Doesn't go up a lot, but it does go up. So what does that mean about the y values? Are they getting bigger or are they getting smaller if we're going up? That's also greater than or equal to. So the domain is x is greater than or equal to 0. The y's are greater than or equal to 0. Now there's only one little bitty catch here, guys. We know the domain and range as the x and the y. The problem here is, if you look at the equation we're working with, did they give us x and y in the equation? No. The two letters they gave us were d and t. Those were the variables they used. So, over here when I wrote x is greater than or equal to 0, the variable that I should be using is the what? The d. Alright, so I'm going to use d is greater than or equal to 0. So that's what we're going to use instead of the x. Same thing with the y. Instead of using y, we're going to use a t. T is greater than or equal to 0. So just make sure you use the same variables that are in the equation, and don't just use the x and y. Alright, so that takes care of number 10. That's the domain and the range. Let's look at number 11. Number 11, they're asking us for the inverse of y equals the square root of 3x plus 6. Well, what do you know about inverses? The x and y is switched. So that's the first thing we're going to do. We're going to switch the x and the y. The y is now the x. The x is now the y. So here's what I'm working with. All I do is switch the x and the y. At this point, I need to solve for the y. What is y? So I need to get rid of this square root. The opposite of square root is the square. We're going to square both sides of the equation. So if I square the x, that gives me x squared. If I square the right side, I get 3y plus 6. I'm solving for y, so the next thing I'm going to do is subtract 6, which means now I have x squared minus 6 equals 3y. We're getting close. I want y by itself. There's one last thing I got to do. Anybody think they know what I got to do? Divide by 3. Divide both sides of the equation by 3. So now we got y equals, a couple of different ways we can write it. We can do x squared minus 6 divided by 3. There's one option. Or we can do y equals, and actually take each one of these and divide it by 3. In other words, 1/3 x squared minus 2, because that's what 6 divided by 3 is. 6 divided by 3 is 2. Okay, so we can either do it this way or this way. Now, let's not forget, guys, we did just find the inverse, and there was a certain way that I showed you to write the inverse function. There was a certain notation. Anybody remember what we used instead of a y? When we wrote the inverse. F with a what? -1. Here's what we did. We wrote it with this notation right here. So that's what I'm going to ask you to do on the test. When you write your answer, rather than using the y, use this notation. So again, the answer can be in this form. That would be one option. We can do that. Or we can do the other, 1/3 x squared minus 2. That would also be acceptable. Either one of these would work. Just make sure you use the right notation. All right, number 12. Number 12 is just like 11. We're finding the inverse. What is the inverse function of y equals 1/3 x squared minus 2? All right, so let's see what we get here. We're going to start by switching the x and the y. Now that I've switched the x and the y, we're actually going to solve for that y. So let me subtract 2 first. X minus 2 is going to equal 1/3 y squared. I need to take care of that 1/3. If I take 1/3 and flip it upside down, that's called reciprocal. That makes it a 3. So I'm going to take both sides and multiply it by 3. This way, all I have on the right side is a y squared. Now, here's where we've been messing this thing up all day long. Some people have been writing this as 3x minus 2, which is incorrect. And that's because I need to take this 3 and multiply it by the left-hand side, which means I'm going to have to use a little distributive problem. So 3 times x is 3x. 3 times -2 is -6. Almost there. Almost. All right, what do I got to do now? Square root. Opposite of squaring is square root. Now I've got the y by itself, and it ends up being the square root of 3x minus 6. What we just found was the inverse. Gilbert, do you remember what way we said we were going to write the answer, what notation we were going to use instead of y equals? How do we do the other? F. There you go, the little -1, and in parentheses x. Okay? And then, of course, the square root of 3x minus 6. So this would represent the inverse of that y equals 1/3 x squared plus 2. All right, same one. Number 13. 13, in a hurricane, the sustained wind velocity, that's the v, the velocity, is given by the function v of p equals 6.3 square root of 1013 minus p. The p is going to represent the air pressure at the center of the hurricane. They're asking us to estimate the air pressure. So they're asking us to find p. And we're going to find that p when the velocity is 64.5. So we're going to replace this right here with 64.5. And we're going to be looking for that P, or pressure. There's the equation we're working. I want to know what's the P. What's the pressure in the middle of that hurricane? So this is like what we're doing on Friday. I want to solve for P. So here we go. Remember we said we can't have anything outside of the square root. So what I'm going to do is divide both sides by 6.3. 64.5 divided by 6.3 is, what is that? 10.23. Well, that's pretty close, right? 10.238 something. All right, so that's the decimal. But we need to take that decimal we just found there, and we need to square it. We need to square both sides. So take that decimal you just found and square it. What do we get? Should be something like 104.81. That's what we get after we square it. We're getting close here. I'm solving for p, so the next thing I'm going to do is subtract the 1013. So again, put that in your calculator with that. Well, no, because that 1013 is a positive. And the opposite of positive is negative. All right, so if we subtract that, we come out with something like negative 908.18, something like that. At this point, the only problem with what I have here is that we have a negative in front of that p. And to fix that, we're going to divide by a -1. That'll fix the negative sign. And of course, you know when you divide by a negative, all that's going to happen over here is it changes to a positive. So now we got 908.18. But notice right here, they do say to round our answer to the nearest whole number. So if I round that to the nearest whole number, we're going to end up with 908. So the final answer to number 13 is 908. Now make sure when you get on the test there, if it says round to the whole number, make sure you do that. 908. If you put 908.18, I'll give you partial credit, but if you want the full credit, make sure you round to the place value that they give you. All right, number 14. A lookout on a submarine is 8 feet high above the surface of the water. The greatest distance d in miles that the lookout can see on a clear day is given by the square root of the quantity h multiplied by 3/2. A ship is 4 miles from a submarine. They want to know how high would the submarine have to raise its periscope in order to see the ship. So we got to come up with an equation. And this equation that we come up with is going to give us the distance d. And how exactly is it going to give us the distance d? Well, it tells us right here. To do that, we're going to take the square root of the quantity h multiplied by 3/2. So in other words, the square root of 3/2 h. So here's the equation we're working. Now we can answer the question. And that question was, a ship is 4 miles from a submarine. How high are we going to have to raise the periscope? All right, so we know the distance is 4 miles. So I'm going to replace the d with 4. The question is, how high do I have to raise the periscope? So here's what we're working. So I need to solve for h. So I'm going to go ahead and square both sides. 4 squared is 16. If I square this side, I have 3/2 h. I'm solving for h, and right now next to that h is a 3/2. So what I'm going to do is multiply by the reciprocal. And the reciprocal of 3/2 is 2/3, 2/3. So that's what I'm going to multiply both sides by. So now I know that h is equal to, I don't know, what is 2/3 times 16? Two-thirds times 16. What's that? 10.6. Now notice on this one, they didn't tell me exactly where to round my answer, so I can put pretty much anything that's close to 10.6. I can do 10.6, 10.66, or 10 would even be just as good. All right, last one, number 15. The formula P equals the square root of L divided by 32 can be used to approximate the period of a pendulum, where L represents the pendulum's length in feet, and the P is the pendulum's period in seconds. Now, when they say pendulum, guys, you guys know that that's referring to that, like a clock, which swings back and forth. Okay? A period just represents from one side to the other. That's a period, one side to the other. All right, so what we're looking for is, if we know it takes 2.6 seconds per period to go from one side to the other, then what is the length of this pendulum? So let's replace the P with 2.6 so that we can find the length, which is L. Solving for L. So the first thing I'm going to do is square both sides. 2.6 squared is 6.76. Of course, on the other side, all I have is L divided by 32. And the opposite of dividing by 32 would be to multiplied by 32. So 32 times 6.76 would give us a final answer of what? 216.32. Well, close. Close. Look at the last part of the sentence. What is the length of the pendulum to the nearest 10? So what would I write to the nearest 10? 216.3. So again, make sure when you're answering the questions, you really read the question and make sure you round to the appropriate place value. In this case, it was going to be 10. If it doesn't say what place value to round, then you're okay, as long as you're close. All right, so that takes us through our review. Test will be tomorrow, guys. Test.